probability that a thermometer used shows either more than 2 degrees Celsius. If 4 thermometers are used, what is the probability that 3 of them show either more than 2 degrees Celsius and 1 show less than 2 degrees Celsius? So to answer this question, many of us started this way, that let's say that the first three, these are more other, more other, more other and less other. The probability of more other we already know is 0.2. So the first thermometer has a probability 0.2 to show either more than 2 degrees Celsius. Similarly, for the second thermometer, the probability is 0.2. For third thermometer, 0.2. For fourth thermometer, it is 0.8. Because if the probability of more than 2 degrees Celsius is equal to 0.2, then probability of less than or equal to 2 degrees Celsius will be equal to 1 minus 0.2, that is 0.8, because the probability of these two cases should be equal to 1. Now, so this looks like the answer. However, let me tell you that this is not the correct answer. The question is that we did not think that which 3 thermometers are showing either more than 2 degrees Celsius. And also, according to my suggestion, let me bring in that perspective as well, that since we are taking the arrangement into account here, so we have to ensure that we have taken the arrangement of the 4 thermometers in which the thermometer which is showing the error less can be at any one of these 4 places. So while we have the first case like this, the second case could be when the less error thermometer is at third number, third possibility is when the less error thermometer is at second place, and the fourth possibility is when the less error thermometer is at first place, and the remaining 3 places have more places. So the same probability will be calculated in these 3 cases, like 0.2 into 0.2 multiplied by 0.8 multiplied by 0.2. Like this, we can calculate the probability for each one of these 4 cases. And because we have these independent cases, so we'll have to multiply, we have to add the probability of all these cases, which comes out to be 0.2 multiplied by 0.2 multiplied by 0.2. That means 0.2 cube multiplied by 0.8 multiplied by 4. So that becomes our answer, which is option C. Alternatively, the answer of this question could have been given in this way, that we have 4 places and 3 places for thermometers with more than 2 degrees Celsius error can be chosen in 4C3 ways. So the required probability will be, we are first choosing 3 places for those thermometers which are showing more error. Let's assume that those 3 places are these 3. So the probability for each one of these 3 places will be 0.2 times 0.2 times 0.2. And for the fourth place, the probability of thermometers showing less than 2 degrees Celsius error is 0.8. And that becomes the same answer, that means 4 times 0.2 cube times 0.8. So the answer is C option, but these are 2 different explanations that probably cleared it out, that why are we multiplying 4C3, because we have these 4 cases to take into account. Thank you so much for watching this video.